Okay, hello everyone. Welcome to the practice 3 of mathematical statistics. Today we will talk about something about z-test and t-test that is used for estimation and hypothesis test. This is our learning goals for today's class. We have 4 points. The first one to master how to estimate the 95% confidence interval with z distribution and t distribution. The second one, to master the procedure of one sample z-test and t-test. The third one, to master the procedure of the paired t-test. And the last one, to understand the independent samples t-test. The first one, let's review what we have learned in our medical statistics class. The first one is about estimation. We can use the method which is called confidence intervals. But when we use confidence intervals method, we need to notice the precondition because there are two methods in confidence interval estimation. Actually, these two methods are based on two different distributions. The first one is based on z distribution and the second one is based on t distribution. And the difference between these two methods is the precondition. So the first method, which is based on z distribution, the precondition is with known sigma, namely the sigma is given. Okay, so here the determination of a 1 minus alpha confidence interval for the mean of normal distribution with known variance or with known standard deviation of population. We can use this formula. This one, we can use this formula. And here we can find that this is x bar. X bar means the sample mean. Here is sigma. Sigma equals to the square root of variance. So when variance is given or sigma is given, we can know this number, sigma, that is the standard deviation of a population. The little n, that is the sample size or the numbers of persons in the sample. So we can find that mu, which is the population mean, we want to know, and we find that mu is between two numbers. The first one is this part and the second one is this part. Mu is between these two numbers, so the smaller number we call it the lower bound and the other one is the upper bound of the confidence interval. And the difference between these two numbers we can find is here. In the lower bound, this symbol is minus, and in the upper bound is plus. So that is the difference between these two numbers. So all we need to do is to put all the numbers into the formula and do some calculations. But notice that the confidence interval is normally used when an interval estimate of mu is desired in which the probability of the interval actually covering mu is 1 minus alpha. So here 1 minus alpha is a probability. The probability means we use the data of the sample to calculate a range which is consisted with the lower bound and the upper bound, and this range can cover the population mean, namely mu, but the probability for the range covering mu is not 100% but 1 minus alpha. Most oftenly, we need to calculate the 95% confidence interval. That means the probability should be 95%. So 95% equals to 1 minus alpha. So alpha equals to 5%. So that is 0.05, right? When alpha equals to 0.05, z half alpha, which is the number we can find from table A1. That number, if you check from table A1, you will find that z half alpha is 1.96. So we just put out the other numbers with 1.96 into the formula, and then we can get the final answer. Okay, let's see some examples. In blood test, 100 female Asian immigrants performed, and the mean level X bar is 181.52. Suppose the sigma is 40. Find a 95% confidence interval for mu. So here we can find that the purpose of the research is to calculate the confidence interval. So we can just use this formula. And next one, let's find if there is sigma in this question. Yes, it's here. Sigma, right? Suppose the sigma is 40. That means sigma is given in this question. So when we want to calculate the confidence interval with the given sigma, we can use this formula, and we find that the probability for the confidence interval is 95%. So that means alpha equals to 0.05. So z half alpha is 1.96. We have mentioned that this number, you need to remember this number. When alpha equals to 0.05, the z half alpha equals to 1.96. Okay, so we just put all the numbers into the formula. This is X bar, this is z half alpha, this is sigma, this is the little n. Okay, so finally we get the answer. The 95% confidence interval is between these two numbers, 175.56 and 187.48. So that is the final answer to the question. Okay, the method of of confidence interval estimation is based on t distribution. So in this condition, sigma is not given. So that means the precondition for this method is sigma is not given, or variance is not given. So here, if we do know sigma, so how can we use the formula? We need to replace sigma with S. We said that sigma is the standard deviation. S is standard deviation 2, but they are different because sigma is standard deviation of a population. S is standard deviation of a sample, so they are different. So here, when sigma is not given, we can use the sample standard deviation S to replace sigma. And here is another difference. When sigma is given, we said that it follows z distribution. So here we use z half alpha, that is 1.96 when alpha equals to 0.05. But when sigma is not given, it doesn't follow z distribution, but t distribution. So here we use another number, that is t value, not z. How can we get t value? We can check it from table A2, that is the t value table. So in table A2, if you want to find a t value, you need two numbers. The first one is nu, or we call it degree of freedom, df. And nu equals to n minus 1. N is the sample size. This is the first number you need. And the second number you need is alpha. So we have mentioned that if you want to calculate the 95% confidence interval, alpha equals to 0.05. But please notice that in T table, we need to use two-sided. So that means we need to use the two-sided alpha. That is the same with what happened in Z distribution. Half alpha, that they are the same. So here we need to use these two numbers to find a t value. The first one is n minus 1, that is nu. And the second one is two-sided alpha, that is 0.05. And with the help of these two numbers, you can find the t value from the table. And the last things are put the numbers into the formula and get the answer. Okay, so let's see another question. Blood tests are performed on 100 female Asian immigrants, and then the X bar is this number. With standard deviation is 40. Find a 95% confidence interval for mu. We can find that the same purpose. Find a 95% confidence interval. So, is this question the same way as the last one? No, they are not the same, right? Let's go back to the last question. Here, we find that the key point is here. Suppose the sigma equals to 40. That is sigma, right? Sigma is given. But in this question, we can find that here is a standard deviation. Standard deviation is still 40. But is this standard deviation sigma or not? No, it's not sigma. We can find that this standard deviation is calculated from the 100 immigrants, right? So that means this standard deviation is from 100 persons. So that is not a population but a sample. So here this standard deviation should be standard deviation of a sample. So that means it is S. So S equals to 40. So here sigma is not given. So we cannot use Z distribution method. We need to use the method based on T distribution. So we need to use this formula. We just put all the numbers into the formula. So this is the answer to the question. We can find that the 95% confidence interval is mu is bigger than 164.23 and less than 235.77. So that is the answer. Okay, so that's all for the estimation. So next one, let's talk about hypothesis test. So in hypothesis test, we have mentioned two methods too. The first one is based on Z distribution, and the second one is still based on T distribution. And the difference between these two methods is still the precondition, that is, whether sigma is given or not. Okay, so here, the first exercise. A study is devised to determine if the average cholesterol level of offspring of men who died of heart disease is evaluated above normal. Suppose a mean cholesterol level in children is 175. So let's think about this number. We find that this number is the mean of cholesterol level, but there is no any numbers of persons which we get this mean. So that means this is the mean of a population. So actually this is mu. Mu equals to 175. We use mu 0 to represent this number. And next one, a group of 10. So here we can know that this 10 is the little n, the sample size, right? 10 children whose father had died from heart disease were found to have a mean of 200. We can find that this 200, this number is calculated with the data of 10 children. So that means this number is x bar. Okay, so next one. Suppose the population standard deviation is 50. So here we can find that this standard deviation is from a population. So that means this one is sigma. So that means sigma is given in this question. So we can use Z distribution because the sigma is given. Next one, test the hypothesis that the mean cholesterol level is different in this group with the general population. Okay, so we can find that this is the key words. We said that when we find that the purpose is to identify the difference between groups. That means you can use hypothesis test, not estimation. So, do you remember the procedure for hypothesis test? That's very important, right? We have mentioned that in our class. In the procedure of hypothesis test, we have 3 steps. Step 1 is to establish the statement of hypothesis. We have 2 statements. The first one, we call it H0, that is null hypothesis. And most often in null hypothesis, that means there is no difference. Or we can say A and B, they are the same, or A equals to B. That is the null hypothesis, which is what we want to test, right or not. And we need another hypothesis, another statement, that is HA, the alternative hypothesis. And the alternative hypothesis should be different. A and B, they are different. So that means A is not equal to B. And don't forget alpha. We need to cite a number of alpha. And most often we use 0.05 as the number of alpha. So that is what we did in step 1. In step 2, we need to figure out a test statistic. For example, in z-test, we need to calculate z value. In t-test, we need to calculate t value. In step 3 is to make the decision, reject H0 or not reject the H0. And we have learned that in our class how to know if we can reject or not reject H0. We need to compare the probability for the test statistic with alpha. If the probability, namely the capital P, is less than or equal to alpha, we need to reject H0. But if P is bigger than alpha, we cannot reject H0. So that is the step 3. And the last one is the conclusion. So if H0 is rejected, the conclusion should be the population mean is significantly different from the hypothesis value at the alpha level of significance. But if H0 is not rejected, that means the population mean is not significantly different from the hypothesis value. So that is the conclusion. You can choose either one from the 2 based on your decision, reject or not reject. Okay, so that is what happened in z-test. And here let's read this question. A study is devised to determine if the average cholesterol level of offspring of men who died of they are the same. The sentence, they are the same. So let's see what is the difference between these two questions. Oh, it's here in the right color. Let's compare this question from the last one. This one, we can find that suppose the population standard deviation, but here is with the sample size deviation 50. So what's that mean? We can find the conditions are similar. This is mu0, this is the little n, this is the sample mean, and is this number sigma? That is the most important thing you need to know in this question. We can read the whole sentence, and you will find that this number is from these two children, not from the population. So that means this number is not sigma. So that means sigma is not given in this question. So you cannot use z distribution. You need to use t distribution. So we call it t-test. So this number 50 is actually standard deviation of a sample. So that means this is S. Okay, so here the same purpose of the research to identify the difference between the two groups. Okay, so are there any difference between the procedure of z-test and the t-test? Yes, there are some little difference between these two methods. So the first one, let's see what happens in z-test, and we said that is used when sigma is given, and we will find that the step 1 is to establish two statements. This is h0, mu equals to mu0. In this question, mu0 should be 175, and ha is not equal, and alpha is 0.05. In step 2, we need to figure out the test statistic. And please notice that this formula is used in the first question with the given sigma, not the second one, because the first question is based on z distribution, but the second question is based on t distribution, not z distribution. So here, this is the formula for z. X bar minus the given population mean 175 over sigma over square root n. We have already know all the numbers from the question. We just put all the numbers into the formula, and then we can get the z, the test statistic. And next one, in step 3, we need to decide reject or not reject. So how can we do that? We need to do some comparisons. We need to compare this z value, what we calculated with the data in the question, with another standard value of z. So how can we know what is the standard value of z? We need to check it from table A1, from the z table, by using the alpha. We said that alpha, when alpha equals to 0.05, that means z half alpha is 1.96. And we need to compare the absolute value of z with 1.96. If the absolute value of z is bigger than 1.96, that means p is less than alpha, so we need to reject h0. But if we find that z is less than 1.96, that means p is bigger than alpha, so we cannot reject h0. So that is the answer. And the last thing is to make the conclusion. But this is the method 1. In method 2, it's used when sigma is not given. Sigma is unknown, so it's based on t distribution. So that is what happened in the second question. We can find that the same step 1 but different step 2. Here we need to calculate the t value as the test statistic. And this is the formula for t. This is x bar. This is still mu 0. And this is the given standard deviation of sample. This is the sample size. And we also need to do some comparisons. We still need to find a standard t value from the table A2. And if we want to find this standard value, we need two numbers. The first one is still new, which is equal to n-1, and the second one is two-sided alpha, and we have already know that alpha equals to 0.05. So with these two numbers, we can find t from table A2, and we compare the absolute value of t with this standard t. And it's similar with what happened in z-test. If t, the absolute value of t, is bigger than the standard t, that means p is less than alpha, and we need to reject. But if absolute value of t is less than the standard t, that means p is bigger than alpha, so we cannot reject h0. Okay, so that is z-test and t-test, but we can find that in either t-test or z-test, we can find only one sample size from the question. So we also call it one sample t-test or one sample z-test, because there is only one sample. But what will happen when there are two samples? So that is paired sample t-test and independent samples t-test. Okay, so here this is a question about paired sample t-test, and we said that in paired sample t-test there will be two samples, and these two samples are matched. So what's the meaning of matched? The most commonly model of matched is before and after. We test a person before he used a medicine, and we can get a number, for example A, and we test this person again after he used the medicine. We can get another number B, and we find that these two numbers are from the same person, and we said that these two numbers are matched. So we call this pair of numbers are paired samples. So you can find some keywords in the question if the question is about the paired samples. The most commonly keywords is before and after. For example, in this question, we can find that it's here before and after receiving the drug So that means before and after, that is paired samples. Okay, so here is the data for the question. This is before, this is after, and we can consider this data as two samples. Sample 1 is before, sample 2 is after. So there are two samples. So that is different with what happened in one sample t-test or what happened in one sample z-test. So how can we solve this question? We need to use paired sample t-test. Okay, so how can we solve the question? You need to do some calculation with the data of before and after. That is the difference. You need to calculate the difference between before and after. So you need to use, for example, after minus before. So for patient 1, this pair of numbers will use 128 minus 115, and we can get the difference is 13. And for the second person, the same thing. After minus before, we get 3. And for the third person, the same thing. After minus before, and we can get a negative number, negative 1. It doesn't matter. We just list all the numbers of the difference in this column. And then let's see the procedure. It has the same procedure, step 1, step 2, step 3, and the conclusion. But in step 1, the two statements are different from what happened in one sample t-test or one sample z-test. We can find here is mu d equals to 0 and mu d is not equal to 0. Mu d means the population mean of the difference, what we calculated in the last column. And alpha is still 0.05. This is the step 1. In step 2, we need to calculate the test statistic, that is t. We need to calculate it with this formula. And this one, d bar, is the mean of the difference. That means we need to figure out the mean of all of these numbers of difference. And SD is the standard deviation. You have already know how to calculate the standard deviation in practice 1 and practice 2. So we need to use all of these numbers of difference to calculate the SD, the standard deviation. This is the little n. The little n is the number of difference. We can find that we have 10 numbers of difference here, so the little n should be 10. So we just calculate all the numbers we need and put all the numbers into the formula, and finally we can get the t value. And the last things are the same with what happened in one sample t-test. We need to find a standard t value from the table A2 by using two numbers. The first one is nu equals to n minus 1 is 9 in this question, and two-sided alpha 0.05. We need to use these two numbers to find the standard t value. And we find that from the table A2, the standard t value is 2.26, and we need to compare the absolute value of t, what we calculated with the data from the question, and we find that the absolute value of t is bigger than standard t. So that means p is less than alpha. So we need to reject H0. So the conclusion is the drug significantly reduces the blood pressure at the 0.05 level, because before and after they are proved to be different. Okay, the last part of today's class is two independent sample t-test. So that means there are still two samples, but these two samples are not matched anymore. So if we can find two samples in the question and without the keywords such as before and after, that means it must be two independent samples t-test. Okay, let's read this question. We can find two samples in this question. This is sample 1, and here is sample 2. And we can find that the little n for sample 1 is 8, and for sample 2 is 21. And we can still find that this is the x bar for sample 1. We use x bar 1 to represent this number. And this is the S1, the standard deviation of sample 1. And here we can find x bar 2, the second x bar, or the sample mean for the sample 2. And here this is S2. So the hypothesis for two independent samples are complex than what we learned before. The formula is complex too, so you do need to remember the formula, and you can find that in our today's learning goals. It's just understand, that is okay. Okay, so here we list all the informations which are given from the question. And here, this is step 1. And you just need to copy the step 1, that is okay. In paired sample t-test, you can do the same thing, just copy the step 1. So here, H0 is mu1 equals to mu2. The alternative hypothesis is mu1 not equal to mu2, alpha equals to 0.05. And step 2, this is very special. In two dependent samples t-test, nu equals to n1 minus n1 plus n2 minus 2. So in this question, nu equals to 27. This is the formula for t. That is a little difficult for the calculation. So we need to use x bar 1, x bar 2, and 1 and 2, and this one, this special number, that is SC. SC, we can use this population to figure it out. So in this question, we can find N1 and 2, that is the sample size of the two samples, and S1, S2 are the standard deviation for each sample. So you need to use the second formula to calculate SC, and then put it into the first formula, and finally we can get T. The last things are the same with what happened in the other questions. We need to find with alpha and nu, we need to find the standard T, and we need to compare the absolute value of T to the standard T. If this one is bigger, we need to reject H0, but if this one is smaller, we don't reject H0. Okay, so that is the two independent samples t-test. That's all for today's practice class. Next one, I will give you some questions about estimation and hypothesis test we have learned in today's class, and you need to finish all the exercise you need to finish all the quiz and upload your answer by taking pictures. Okay, so next one, you can finish your homework.